Hello, hello! Welcome to the stream. David Snowpeck here from Snowpeck Games. Let me get our stream overlay thing situated. Oops, didn't mean to remove you guys. Gotta remember all the key codes. By the way, this stream overlay is something that we built in Godot a couple of weeks ago on stream. And what makes it green? Something makes it green. There we go. Give me a second. I'll get it so it's actually covering up my my screen so you guys can be bouncing around. Looks like we got a few eyeballs. By the way, I don't know who is watching unless you say something, and then you'll get a little character on the overlay as well. So let me fiddle in OBS for a second here. And all right, let me know if the stream overlay is working. I can't actually see it while I'm displaying it. I don't have enough monitors to make that happen. In any case, how's everyone doing this week? I've personally had a crazy week. My kids started school on Wednesday, which threw the family schedule and my work schedule and everything up in the air. But yeah. Let me know how you guys are doing while we're waiting for some people to join. Since, you know, the first couple minutes of the stream, always it takes a little while for people to trickle in. I wanted to show you guys a non-Godot thing I've been tooling around with. I showed it at the beginning of the last stream also. Oh, and of course it opened on the wrong screen. Hang on a second. All right, so is the overlay working? Anyone saying it's not working? Nobody's saying it's not working. All right. So this is a little prototype I've been making in assembly, 6502 assembly, for the Commander X16 8-bit computer. It's kind of like a little Mega Man clone thing, is the idea at least. I did not make the art. This is just art I got from itch.io. But if you remember from last week, there was no collision detection, and he could jump, and he couldn't shoot. So now, you know, I can collide on all sides and, you know, not fall through the earth and bump my head. And if I walk off a ledge, he will fall. He'll fall at a rate much higher than he should. There's a bug with gravity. It's funny to say that phrase out loud. There's a bug with gravity that I still have to fix. But the camera is moving. The background is parallaxing. I will not make all of these jumps, I'm sure. I'm not very good at my own little Mega Man clone here. I'm falling through the earth. So you get to see another bug here. I'll fall through the earth a couple of times. And eventually I will collide again. The reason that he falls through the earth is because the screen dimensions, according to the video card, because he's just a sprite and there's hardware sprites on the X16. There we go, he landed. Is much shorter than the virtual world space, because I'm using a it's a fixed point number where I'm using 20 bytes for the whole number part and 20 bits for the whole number part and 4 bits for the fractional part. And so he's got to fall through a couple of times before he loops around on the virtual world space. So anyway, you know, I got a little bit burnt out from all of the physics stuff we were doing, all of the trig. It was enough for me, so I decided to cleanse my palate a little bit by working on that little 8-bit prototype. But that's, of course, not what we're going to be working on today. We're going to be digging into some Godot stuff. Let me see what everyone else is saying before we move on, though. ACB Games, who's also working on a stream overlay thing, asks, have you looked into making an HTML5 export of this and running it in OBS? I mean, I am running it in OBS, but as like the thing where OBS captures a window. Running it in HTML5 is a possibility that would actually solve the problem that I'm having where I can't show it because I don't have enough screens to put it on. It has to be actually visible on one of my whole screens in order for OBS to capture it. I can't like put other things in front of it or whatever. But then I don't know how I would give it commands. So if it was an HTML5 thing and it was running in OBS's like embedded browser thing where you don't even have to see the browser window, in fact you can't see the browser window, I don't know how I would hit like the key commands to turn on the music and turn off the music and start the timer and stop the timer. I'd have to have like, I don't know, some other way of communicating with the app, and that just sounds hard. But you know, it's just a little fun thing that we made on stream. I probably will continue making it better in little ways as we go, and I'm definitely open to suggestions. Elliot Christensen says, "Oh yeah, X16, yeah." Thanks, Elliot. you and me, I think, are the only retro computer enthusiasts who hang out on my stream and in my community. But I'm happier here. It makes me feel better. Is this just to challenge yourself? The stream overlay? Yeah, I mean, just to do it. Oh no, to challenge myself, the assembly thing. Yeah, because it's fun, man. So my first computer was a Commodore 64, and the Commander X16 is like a spiritual successor to the Commodore 64. And one of the main regrets of my childhood was that I didn't learn assembly. So I learned to program on the Commodore 64, and I programmed in BASIC, and I made games. That was the start of my game dev career, air quotes. Was making little games in BASIC for the Commodore 64, but I never learned assembly, and so, I don't know, it just hit me one day. It was actually shortly after I finally threw away my Commodore 64, which I'm regretting a little bit. But I threw it away, and then like, oh, I'm never going to even turn this thing on again. I haven't turned it on in like 15 years. And then suddenly, like, it hit me, and the nostalgia, and I was like, I should finally learn 6502 assembly. But yeah, it's just super fun. It's crazy to think they did an assembly. It's not very good assembly, man. It's not. So the collision detection that I'm so proud of right now, it's like hundreds of lines of code. I'm sure there's 1,000 better ways to do it. I made some notes the other day. It's something while I was eating breakfast occurred to me, a way I could optimize the collision detection, make it a little more flexible, write it in maybe like some hundreds less lines of code. But yeah, it's super fun. Yeah, so what are we actually doing today? Well, let me show the game really quick. Retro Tank Party. This, for anyone who's new to the stream, this is a online multiplayer, you know, for PvP tank battle royale kind of thing. And there is already a stable version on Steam and itch, and we have been, for the last 10, 11, 12, something like that, weeks, been working on converting the multiplayer netcode from the kind of naive synchronization method that it's using currently to rollback and prediction, which is commonly used in competitive fighting games. The GGPO library, if you've ever heard of that, is a common... Ooh, I crashed it. So the version that I was just playing right there, that was practice mode in the version that we're hacking on. So it's kind of like half converted to rollback and prediction. So there are loads of bugs in it. But the last several weeks, maybe 4 weeks, something like that, we've been trying to tackle deterministic network physics. So up until this point, we had just been working on the netcode with Godot's existing physics engine, which works fine. I use Godot's physics engine in like all of my games. Maybe there was one where I didn't actually use physics, but it is not deterministic. And one of the requirements for rollback and prediction is that you use deterministic physics, because you need to have it so that two games with the exact same state, given the exact same inputs, will respond exactly the same down to the binary level of their, you know, positions and rotations and all of that. So we've been developing this fixed point physics engine in C++ as a Godot module. And yeah, lots and lots of C++. And we finally got it to the point, it's not totally done, but we finally got it to the point where we can start integrating it into the game. And so that is what we're going to start on today. And unfortunately, I have to admit that I have not worked on this at all since last stream. Usually, like, you know, from one stream to the next, I, you know, do all this stuff and I'm talking about, oh, I did all this and I did that and have all these cool new things. I did not. I like I said, I kind of burnt out on it a little bit, and so that's why I was working on, you know, the Commander X16 app. So we're picking up like exactly where we left off last Friday, and yeah, I'm kind of thinking that we will start by just making that practice mode work. You know, of course, the whole point of this is to get the multiplayer, you know, going. But right now, we just need the physics to exist in the game and not totally break, right? So, where to start? Where to start? I think we will start with the tank itself. So, man, it's been a long time since I've been in this code. My brain's just all assemblyfied. So that is an object, right? Yep, object will load up the tank scene. And we have been making our own kind of set of physics nodes that mirror the, hey, the clean! I can't see what you're saying because your text is all gobbledygooked on the screen that I'm looking at. But it's good to see you. I'll see what you actually wrote in a moment. So we've been making our own versions of the Godot physics nodes, and we're going to need to convert from the built-in ones to ours. And I'm not sure what the best way to do that is with the least amount of work. Of course, I can right-click here and click Change Type, but I'm worried we're going to lose a bunch of these things. So we might want to write some of them down. Or the other option is actually we could just manually edit the TSCN file and change which node it is, and then we can see the properties there and say like, oh, well, this property is actually called and change the name. But I think what I'm just going to write this down, and once we get kind of a feel for it, hopefully I'll have a better system. I'm just going to say it's on, layer 2, mask 1 and 2. The position is at 0. So changing the type to our custom SG kinematic body to D. That is our version of the kinematic body. Let's see what happens. Change. Do it. Ooh. Ooh. Oh, we had a breakpoint set. I was about to say, we've caused a seg fault already? No, not quite. Let's continue. See what happened here. We are now an SG kinematic body. Let's look at collision. Ooh, the collision layer stayed. I guess we named the properties the same as they were in the built-in Godot core one. The position was 0, 0 anyway, so that's fine. All right. Step 1 without incident. At some point, I'm sure this is all going to totally explode. Let me see what's going on in chat real quick. Oh, the clean just is giving us some Vulkan love here. All right. So the next thing, in RetroTank Party 1.1, I converted the collision shape from a rectangle to a polygon. And ever since we decided we were going to write our own physics engine, I have regretted that decision. I don't think it would be that hard, actually, to implement the polygon collision. The collision in our physics engine is using SAT testing, which would work with polygons just fine. SAT testing a rectangle to a polygon just means testing a whole lot more axes. I guess I'm trying right now to find the code where we have all of our SAT tests. And I cannot remember exactly where that is. That is in Collision Detector, internal. Yeah, so we basically have, we do let's find rectangle, rectangle. We basically, take all of the axes that make up the rectangles, loop over, we check if they overlap, those two rectangles overlap on one of those axes. If we find an axis where they do not overlap, where if there's a single axis of separation, then we say, no, they don't collide, and we're done. And a polygon would basically just have to have an axis for every single line segment in it. But we're not going to do that because I'm just tired. I'm just tired of math. So we are going to switch this back to a rectangle, which might be fine. The reason that I switched it to a polygon is because the tank would get stuck in really weird ways on obstacles. Because, polygons got square corners, and you look at the tank and you're like, I don't have square corners. So what I think I'm going to do is I'm going to save this polygon resource, which I think I can do, can't I? Can I save this polygon resource? I was hoping I could save this polygon resource as like a TRES file so that we could bring it back later. But maybe we can't do that. That's interesting. I thought the polygon itself could be a resource that we could save. Okay, new plan. Let's do save branches scene. That's going to save this single collision polygon node as its own scene. And let's put that right next to where the tank is. Maybe I'll even put it inside the tank folder so it doesn't distract me. Collision polygon 2D, that's a fine name. I'll make it easy to find it later when I want it back, if I ever want it back. And we are going to delete that guy. Get out of here, collision polygon 2D. And we are going to add one of our SG collision shape 2Ds. SG standing for Snowpack Games, if that was not immediately obvious. We are going to choose, since we only support 2 shapes, rectangles and circles, we're going to grab ourselves a rectangle, and it is behind the tank. That's kind of annoying for drawing this, but I guess fine. I could move the node forward so it would go over it. And we want to give the player some leeway. So let me just think through this. This collision shape is what its movement is based on for sure. Are we using the same collision shape for detecting hits? Sometimes I do separate. Sometimes I do like 3 separate sets of collision shapes. We'll have the movement collision shapes, which is generally physics, and then we'll have hit boxes and hurt boxes. But we might just have one in this case. Let me just poke around in here and try and determine how we are detecting hits. That might actually be on the bullet. Let's go over to the bullet scene. Which descends from base bullet. Let me rearrange my stuff here real quick. On bullet collision can hit body, so bullet collision is coming from what? That looks like signal. No? Wow. Okay, no, now I'm back to bullet. I want base bullet. What's calling on bullet collision? Well, I imagine a signal or something. Okay, no, check collision. Check collision does get overlapping bodies and then calls on bullet collision. And it's brilliant that it works that way because for implementing our deterministic physics, we're going to have to switch away from using signals, which could get called at any time and like we have no control over, to a model more like this where we're saying, specifically we're going to like move our objects and then check for collision and do things. So we'll get overlapping bodies, call on bullet collision. Beautiful. And get overlapping bodies. Yeah, so it's all one shape. I guess the bullet is an area, and it is checking if it's overlapping any bodies, a tank being a possible body, and then generating a collision. Okay, so we have to think about this in terms of both movement and getting hit. So we cannot just like blindly bias it in terms of the player, because the player is both sides. The player is the opponent and... I don't know. I kind of like the idea of it only going out to the sort of wheelbase. Let's try that. We'll see how it feels. I'll move this a little bit this way. Yeah, that looks pretty good. So we just have these weird kind of corners over here, and we have the fact that these back and front edges are going to kind of overlap with stuff. All right. So what else do we need to do? In all of our movement, we're going to need to switch from using floating point math to fixed point math. So let's start at the top with all of our variables and such. We have this velocity vector. I have this really bad habit of declaring like velocity vectors as member variables where I'm overwriting them every single frame, which I guess I'm doing here too. So that bad habit lives on. But actually it might be good for us because Godot core vector 2s are primitive objects, which are allocated on the stack, so allocating a new one is super cheap. But unfortunately, due to limitations of GDScript in Godot 3, ours are allocated on the heap, so we do not want to reallocate them very often. So it actually could be good that this will now become an SG vector 2. Why is it not a valid type? Fixed vector 2, fixed vector 2 for fixed point math. All right, fixed vector 2, which will start out at 0, and we'll need some way to kind of like reset it to 0 over here. I don't know if we gave ourselves a helpful method to do that, or if we just have to set like each of the members to 0. That'd be kind of nice to add like a clear method to the vector. Maybe let's just do that. Like, it's our code, we wrote it, we can do whatever we want. I think that is in our SG fixed vector 2 CPP. I guess we have to start with the H because we have to declare our own, declare a new method here. I'll put it at the top. void clear, and this will set value x value to 0, value y value to 0. And that's confusing because we have a member called value, which is this fixed vector2, which then has individual members, which are our fixed class, which then have a value, which is the underlying integer. And that's just the fastest way to do that. We could have done, something more C++-y feeling like that, and that would have been fine too. But it's a struct. It exposes its internals. We use its internals, so I'm fine doing that. All right. And we have to emit this changed signal for all of the editor stuff to work. That change signal I don't think is used for anything but the editor. In gameplay, it kind of doesn't matter. It's a no op. And let's just bind it and move on. Trying to give a little bit more explanation at the beginning of all of our things, since I know some of you have been on like all of the streams, but I want it to be at least a little bit accessible to folks who are here for the first time. All right, so we bound that clear method. I guess we can rebuild. I'll let it rebuild in the background while we'll still poke around in our editor. Let you rebuild. And all right, so this will turn into clear once that method exists. Then we have our own move and slide, which past SG vector 2 does not match the functions expected. Why? Why not? Oh, okay, so we changed the node, but we did not change the type of the script. Okay, so I guess this descends from base tank, which says it's a kinematic body 2D. We are not a kinematic body 2D. We are an SG kinematic body 2D. Let's go back to tank. Get back to our velocity here. So this should be good. Velocity rotated times speed. Did we leave ourselves some mutable? We left ourselves rotate. Cool. What are you saying? Already running? Do I start in? Okay, I guess, yeah, you gotta do that, please. So normally, vectors have all of these like non-mutable methods. You would say rotated, and it would return to you a vector that has been rotated, a new one that's a copy. We kind of don't want that to happen in this case because, like I said, ours are allocated on the heap. All right, so this is now our new instance. Little switcheroo there. Get back to our tank object. Yeah, I guess. Well, no, open the scene too. Let's open the scene and the script. And get back to our velocity. Okay, so we want to not create a new object. We want to say velocity rotate, rotation. Oh, but our physics engine wants us to do a rotation and slide as well. So, okay, we need to rotate the vector because that will decide which way we're moving. But we actually want to rotate the body before we move. And how do we know how much we are rotating? Okay, so the rotation, this bit right here, we want to replace with our rotate and slide. So rotate and slide. And our amount, we're not multiplying anything by delta anymore. Get out of here, delta. Oh, that's going to mess up all of our speed calculations. Huh. Okay, so turn speed is going to need to be, first of all, fixed point. We need to turn it to a fixed point number. And it's going to need to be a per frame amount, pixels per frame, rather than pixels per second. Again, because we, in our rollback and prediction netcode, everything is based on frames. We do not want anything to be dependent on how long it took that particular frame to happen. We want just always the same amount of movement or whatever on every single frame. So all of these times deltas need to go away, which means our turn speed is going to be wacky. It's going to be way too high, but we can tune that. In fact, actually, it should be easy enough to do the math. So default turn speed. All right. So we have it as 5 pixels per second. And if we say, let's make this big so you guys can see it. Our frame rate is 60 frames a second, at least our rendering frame rate. I know we mucked around with the network frame rate earlier, but we're going to still stick with the 60 frames a second here. Unless I already adjusted that. I might have already adjusted that. Let's take a quick detour, and let's go look in the GitLab repo at the currently released version and see what numbers we have there. Just to make sure I am not double correcting for the same thing. Okay. To get to source objects. Tank. And our... No, okay, default turn speed. Oh, you know what? That is probably fine because delta would have changed when we changed the network frame rate. Okay, cool. So, but a physics process is running 30 times a second. Yeah. I think we're okay. Let's do this calculation based on 30 frames a second, and then we'll see if it was right or not. We'll be able to tell, I think. Okay, so 30 frames a second. First of all, how fast is 30 frames a second? I need more precision than that. Reverse Polish desk calculator. Okay, yeah, that's obvious. My brain is such mush when I'm on stream. Okay, so it's 0, 3 repeating. So 5 times that should give us about that much per frame, and then we need to convert it into our format of fixed point numbers, and we get this amount. So our default turn speed is now 10,922, maybe rounded up to 23 because this comes out as 0.5. Oops, I accidentally zoomed. All right, let's jump back down to turn speed. Get us forward here. I don't like how I don't have Vim key bindings here. I have to do things a little slowly. Ooh, a comment. Hopefully from the stream. I just have my Discord open on this little computer here. Hey, Phil Dew, as I know you on all of the Discords and such, welcome to the stream. Ooh, and you got a pretty cool character. You have a crown or something, like a crown and a beard. Welcome. All right. So this should be good. This rotation, we're multiplying it by speed. So we have to change how this works times speed. We'll have to convert the speed also into one of our fixed point numbers. Doesn't. Oh, okay. I'm all F for multiplying by a single number. That's what we named that, right? Right. We did. Okay. So this might work. Or it might crash horribly. So at this point, all we want to see, ideally, is the tank driving around. We shouldn't expect any collisions to work at this point because we haven't converted any of the other physics bodies in the game to our physics engine, only the tank. So let's try it. All right, well, we're up in the corner, and we've hit a breakpoint. Okay, non-existent clear. What? We just wrote that method. We just wrote this method. Bind method clear, sgfixed vector. What are you talking about? We just wrote that method. Okay, well, clearly I quit the wrong editor or something. We'll just hack around this real fast. I, of course, type way worse on stream than I do normally because of the nervousness. Oh, and we don't even need to clear this X because we set X a moment later. All right, so let's give this a shot. Oop, I don't know why I just ran the scene. Don't want to run the scene. Although I guess we could run the scene. Will the tank scene work on its own? Nope. That could be because it needs to have the whole game working, or because something else is broken here. No, no dice, nothing. Oh wait, we're hitting a breakpoint with value of type int. Invalid set index on nil. Velocity is nil. Why is velocity nil? Oh, okay, so it's no longer an object on the stack. So we need to actually initialize it. Okay, let's initialize it. I think we made ourselves a helper singleton to let us create some vector 2s really easily. Okay, maybe that's what was going on with the clear method not being available. So let's bring that back and see what happens. Okay, okay. Ooh, whoa, and we're spinning. We are spinning, but we are not moving at all. The spinning is good though, because we did that. There's like a little drifting. Look at how it like kind of drifts. That's interesting. So I don't know if you guys can hear that. The engine goes when I go forward and backwards, but it does not actually move. All right, so movement vector. Oh, so this is being calculated in not fixed point values. It's being calculated in normal floating point values, which would obviously be way, way, way too small, about 65,536 times too small. So let's find where movement vector is being calculated. And yes, we'll have to convert this to work with our fixed point numbers. Okay, so let's make a new object here. Say, I don't know, movement vector. Or I guess we declare one down here, we just don't use it up here. Okay, fine. So we can do these ones pretty simply. SG fixed vector 2, 0, 0. What are you saying? SG fixed return type. Oh, okay, we have to change all the return types here. SG fixed vector. And this isn't going to work anymore. So we have our input is coming from our hook default gather input. Is that still being used? Let me just check something really quick. I have this feeling like I might be on the wrong branch, and I do not want to get too terribly far into this if I am on the wrong branch. Nope, rollback physics. That should be the right place. Okay. How does this work anymore, guys? It's been too many weeks since we've been in this code. Like 5 or 6 streams ago. Okay, so get local input. This is the method that's called by our rollback prediction netcode, our little library that we made. And it's dispatching an event to gather input, which brings us here. It's getting the control scheme. And then here it's doing some math. This is floating point math, but is that okay? I think it is. Because this is where the player's input is being generated, and it's only being generated here and then shared with all of the other clients. So I think that's okay. I think floating point math here is okay. And then maybe it's actually fine to keep. No. I was going to say maybe we could just keep it as a floating point vector and convert it at the last minute, but we can't because this input dictionary is what's going to be serialized and sent over the network. So we need to turn this. It's okay to do this in floating point math, but as soon as possible, we need to convert that into fixed point math before we stash it on the input dictionary. So where's the most convenient place to do that? I guess here's where it's being stashed. So let's convert it here. Should be easy enough to do. Did we make ourselves a helper method for it, though? That'd be pretty cool. That would be very nice to ourselves. From float? No? Ooh, what? That's a thing? Sweet! One-liner. Thank you, past stream selves. Can only be called from an instance. What? Okay, so sort of thank you, past stream selves, because you made this very weird. So let's do, I guess we have to make an instance of it. But why? Wait. Okay, SG fixed. Let me just go look at the C++ code here. Where's that singleton object? What methods do we have on it? Ooh, we have some trig stuff on there. I don't remember putting that there. We have a thing that makes a vector 2. Oh, and we have from float to float for individual values, but we do not have them for vectors. Maybe we should let's make that. Let's make that. That is a very nice convenience function, which I guess our past stream selves did not make for us, despite the fact that I thought they had. So we need to return a reference counted fixed vector 2 from float, we'll say vector, from float vector 2. And so that's vector 2. I think we want to do a const reference because C++. Say float vector. And a 2 float. We have that already on this class, I think. Let's go look. Yes, we have a 2 float already there. Okay. So let's wind our way back to where we just were. Make sure this looks okay. I guess we can call it const. I mean, this is a singleton, so like, who really cares? But we'll say it's const. And we'll bind it so that we can access it from GDScript, from float vector 2, vector, we'll call it float vector, and from float vector 2, and the implementation should be like 4 lines. I kind of want to put it, yeah, I have this sort of obsessive compulsive need to put things in order in my code. I don't know why, but I want everything in the CPP file to be in the same order as it was in the H file, and it really makes no difference at all. But SG fixed vector 2, SG fixed from float vector, const vector 2, p float vector const, and step A, we need to allocate it. So that would be ref SG fixed vector mem new SG fixed. Oh, I wonder, does it have like not being able to remember my own APIs. That's gold right there. Let's see if we left ourselves some convenient methods that will allow us to write this in fewer lines. I'm looking for the internal math classes here, since we do have this kind of separation between internal objects that are used inside the physics engine and external objects that expose our physics engine to Godot. And I'm wondering if fixed vector 2 already has its own method for converting from a floating point vector. Looks like no. Okay. We'll just do all the work. It's still going to be like 4 lines. It's fine. It's fine. All right, so we're going to allocate this guy. SG fixed vector 2. We're going to pass in a fixed vector 2. That's the internal object. And we need to convert each of these members to fixed numbers, which that has a convenience from float, p float vector x. Wow, so many parentheses. You'd think we're doing Lisp here. That's because I don't want to. I don't want to have a temporary variable because I don't want to type the type name. That's how lazy I am sometimes. Okay, so fixed from float, p float vector y. Okay, then let's count some parens here. So that one is the fixed vector 2, this one's the SG fixed vector 2, this one is the memnew, and this is the constructor there. Okay, let's see if VS Code likes that. VS Code is happy with this line, it's unhappy about this line. Incompatible, what did I get wrong? Oh, lowercase. And it's good. All right, anything going on chat while I'm doing? Oh, Phil Do says, happy to check this out. I don't know Godot, but always good to have other dev streams up in the background while I'm working myself. Oh, and the clean, I need to check for your comments every time I am having some stupid problem because you always catch my mistakes before I do. Sorry I didn't see that when it was relevant. But yeah, welcome Phil. Hope this is some good background hacking for your foreground hacking. All right. That looks good, I think. And now let's switch back to Godot and let's actually use this. SG fixed will now have a from float vector method, which it will not recognize because we haven't recompiled yet. Return vector 2. Where are you complaining at me? Okay, yeah, so that's just further down in the file. We haven't gotten there yet. Yeah. But I think everything's good in this part. Let me start this recompiling while we're working through the other code. I'm starting to get the hang of like where to interject the C++ recompiles for the stream, so it's not too boring. All right, so we did that. So now our input vector here will in fact be in SG fixed vector 2. So here we can use these values, but we can't return a vector 2. We'll have to convert that to just like another SG fixed vector 2. And how can we do that with allocating a new thing on the heap? Because I'm apparently now obsessed with that. We will there comes our new compiling happening. I saw Elliot said something in the chat. What was that? Oh, the clean says, I was wrong though on multiple levels. Well, it seems, I mean, I did fail to initialize velocity, so that seems like it was close to right. 6502 assembly is way easier and thus better than x86. This is Elliot talking. I'm loving this, Elliot, by the way. x86 has crazy instructions that are practically only usable by a compiler. Elliot says, cool, look at that. Yeah, 6502 assembly is fun because it's almost like RISC instruction set because it's such a small instruction set that you can kind of keep all of it in your head. And any sort of more complicated things you end up like making with those individual components. Of course, it's not a RISC instruction set because different instructions take different lengths of time. And then you have to memorize that. But yeah, x86 is not like 24 instructions. It's like hundreds. Something like that. I should look it up before I start saying things out of nowhere, but it's a lot. All right, so we have our new editor instance. Let me save in our old editor and close it and kind of pick up where we left off. Yes. Every time Godot opens, it saves the project.godot file, which is really annoying when you're doing this kind of stuff with multiple editors. It feels like opening a file should not save a file. But I'm sure there's a reason for that. Let's get back to where we were. Source. source objects, tank, tscn. All right, back where we were, more or less. Okay, so I'm just going to save the individual values on the input vector into like little temporary variables because they are just integers. And can I change it? Or will that create problems? You know, okay, so I was going to change the original object in place, again, because I want to avoid more heap allocations, but I think I don't have a choice here because I think if I modify values that are in this input vector, it'll cause problems later if it needs to roll back and then replay this input that the input will actually have changed because I just modified it. So I do have to return a new vector. Okay, fine. Fine. The C++ memory gods will not be appeased. But otherwise, this code should just be this. I am sort of looking forward to porting this custom physics engine to Godot 4, because then I won't have to deal with the stupid vectors being heap allocated, and that will help my OCD slightly. If I have OCD, I don't think I have OCD, but it will make me be less obsessive about memory things. All right, so now the movement vector here, we're doing in a really odd way. How can we change this to fixed point math? So current vector, we're making a vector out of our current position, or current orientation, and we are recreating that every single time. Would be kind of nice to not do that, but whatever. Screw this optimization. Screw my obsession. Let's just get it done. Let's plow forward here. Fixed. We'll declare a new vector. We do not have constants for right, left, up, down, which we should. That would be cool, but we are just going to do it by hand. So right is 65,536, comma 0, and then we are going to rotate it by the rotation. Where is this rotation coming from? Oh, that is not the right thing. Typo. That is the floating point rotation. We need the fixed rotation, which is fixed rotation. Okay, so that should get us a vector that is oriented the direction the tank is currently pointing. Then the desired vector, because this, okay, so up here, this is the retro control scheme, which is my favorite control scheme for this game. It's tank controls. And then this is the by popular demand modern control scheme, which some people tend to enjoy. In fact, most people. And that works a little differently. We have a vector that the player is telling us to go, and then through here we're calculating how to rotate the tank to make it actually point that way. And this code is a pain. Okay, how about this? Let's comment this code out for now and come back to it, because we don't need to support two control schemes right now. We don't. We just plain don't. We can come back and implement the second control scheme later. So we're just going to say if we get to this branch of code, we're just going to return a vector pointing nowhere. 0, 0 vector. And will this be enough? So calculate movement vector. Where did we leave off here? Calculate movement vector here. That should be returning to us a proper SG fixed vector 2. Time to test our code. Let's see what's going on. Oh, what happened? Non-existent from float vector. We just wrote that function. Oh, did we call it float vector 2? We called it float vector 2. Okay. Let's kill our current instance, add a 2, not a 3, a 2, and run it. Oh, come on. What? Oh, we have a Where is this? Serialize input. Okay. So even though we are running in practice mode, it is still apparently serializing the input to go over the network. That's fun. So this input vector is not a vector 2. It is an SG fixed vector 2. We are not putting a float. We are putting a... Do I have to type U? It's not a U. It's an S. Okay, if it's signed, do I just put nothing? I just put nothing. Okay, it's a signed 32-bit value, so I don't have to put S32. Okay. I'm gonna quick see what's going on in chat real fast, because I did see some people saying some things. Elliot says, David and I are moderately excited because the X16 is simple enough, yet good enough that it will likely have a good ecosystem to make selling apps at least break even. Yeah. Ricardo. Hey, Ricardo. I didn't notice you jump on the stream. If SG vector 2 takes integers, then will the input vector components get truncated there? So... Interesting question. So if the input vector is actually giving us floats, which method are we calling? That is a really good question, Ricardo. You now have me questioning reality and wondering what I just did, which are the best kinds of questions. So that was, we were doing this SG fixed vector 2 and input vector. So these, okay, this input vector should already be integers because our gather input converted these into a fixed vector here. I think we're good. I think we're good, Ricardo. But thank you for making me double check that. All right, so we were on serialized input. Jumping back and forth. And let's try this again. Whoa, look at us spin. We're spinning like crazy. So rotation was working fine before, and now it's like gone wild. And forward and backward movement is still not working. Although it's shifting a little bit. I wonder if it's still a movement speed thing. Let's look at where our speed values are. Ricardo says, "Ah, yes." All right, let's look at our speed values and see if those need to be converted. Why am I in network sync? I don't want to be network sync. I want to be in tank. Tank me! Okay, I've been tanked. All right. Default speed is set to 400, which I guess was 400 pixels per second. Time to bust out our reverse Polish calculator again. Which, is there an easy way for me to clear the screen once I have this open? Because I know there's like a bar at the bottom. I'll just close it and open again. Well, so you guys can see. Don't want to miss any of my reverse Polishness. Or any of, I guess, the forward Polishness? Okay, that's turning into a bad joke. All right, so 400. Peter Sigmund, welcome. Yeah, thanks for joining from Hamburg, Germany. Welcome to the stream. 400 pixels per second. We decided earlier that it was roughly, that was at the delta we were using before. So now, or wait, no, okay, so that was pixels per second. This is pixels per frame. And now we need to convert that into our fixed point values, which is that odd number. Let's give it a shot. 873725, and it's 0.9, so we'll round up to 26. Wow, that's a good number to have a constant for. If anyone ever tells you don't use magic numbers in programming, well, this is a good demonstration of why not to. Ooh! Whoa! 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 All right, so that's not doing what it's supposed to by a lot, but we're moving. We're moving. So the rotation is oddly fast. It seemed like it was right before, and we seem to drift in like a really weird way. What control scheme are we using? Let's just make sure of that first of all. Retro, okay, good, because that's the one that has code for it. And we can go forward. That even feels like the right speed, to be honest. And if I can rotate this way? No, we always just seem to move that direction. Okay, where did we screw up the math? I think we should step through this in the debugger and kind of feel out where we are at. Let's see if there's a good place we can set that where it won't trigger every time, because Godot doesn't have conditional breakpoints, right? No, I don't think the normal Godot debugger, like the one that lets you debug GDScript, has conditional breakpoints. Okay, so if we end up here, that means with a retro control scheme, but it'll get called no matter what. Or no, wait, no. Okay, so if our input vector is 0, then this return will happen. So we should be safe to break here. And that will give us an opportunity to inspect the input vector, which should have been generated by this hook default gather input method. So let's try it. Wow, there's a lot of characters bouncing around. Okay, so I'm going to press, well, I guess I'm going to try with rotation first. I'm going to rotate right. And that gets us to a breakpoint here. Okay, so let's look at input vector first. Input vector is an object, which is x. This is completely right. Does that make sense? Is that what we would expect to happen? Okay, movement is relative to the tank facing right. So y turns to the left right and x moves forward backward. So I pressed rotate right. And I press turn right, so up here. Yeah, okay. I'm not using analog controls. I'm sorry for all of the almost yawns. The yawns I'm trying to hide. Yawning on stream is the worst. I'm now making like 50 people yawn, sorry. So I'm not doing analog controls, so this should be 1, which in our fixed point number scheme, it's 65,536. So that seems fine. Yeah, this turret rotation stuff, that doesn't matter. So we get here, the input vector looks fine. Now, it's converting it here, and based on my comment, which thank goodness I left myself this comment, we are taking y and inverting it. We're not doing any y right now anyway. If I hover over that, will it show it to me? No, it just tells me. That's really weird. I guess that number, the hover number there, the 6967, that must be like the object ID or something. Anyway, so the x value seems right. And we're changing that x value is becoming the y turns left and right. Okay, so if it turns left and right, it says we're picturing the tank facing right. So left turning would be a negative 65,536, and turning right would be positive of the same. So that seems right. Okay, let's keep stepping forward. Where is our, I guess that would be step over. So now we have our movement vector. Let's keep going here. Rotate and slide. Seemed to be working, and now seems crazy. Oh, also, we probably shouldn't be calling this if we're not rotating. I wonder if that's where like this sort of like weird jiggliness is coming from, which might, I guess, be a bug in our implementation of rotate and slide. But for now, let me just add, if movement vector y does not equal 0, then we rotate movement vector times turn speed. And so our turn speed, man, I thought our calculation before seemed good. So, but let's, yeah, okay. We're going to step over. These lines won't line up with what actually is going on because I just changed the code, but this is actually the rotate and slide. And our turn speed. So, our fixed point math, let's get out of the desk calculator. It's not quite powerful enough. We'll go to my other favorite calculator, Python. And we are going to take 65,536 and multiply it by this turn speed. And the turn speed is actually radians. We're actually thinking in radians per second, which makes this number seem really large. It's okay. We'll multiply, and then we have to shift the number, back 16, and this should give us our new fixed point value. Oh, it's 1. Okay, of course. So 1, and then that's how many radians? Divided by, we'll do 0.0 divided by 65, 36. 0.1666 radians, which still seems like a lot of radians, guys. I am not good at thinking in radians, but let's do a little Google conversion here. Radians to degrees. If we're doing 0.1666, whatever, that's 9 degrees per frame. That's way too many. Way too many. We totally screwed up the way we did the conversion. Let's see what folks are saying here. Ooh, Slacks! Hello, Slacks. Thanks for joining the stream. Welcome. What kind of character did you get? Ooh, you got like a orc with a mustache and a kind of bendy sword. I didn't really pay attention to who I am. Am I still here? Oh yeah, no, I did. I kind of look like Hulk Hogan wearing a crown, and I might not be wearing pants. I'm not entirely sure. Whoa, and it looks like Elliot got kicked out of the play area here. There's a bug where like people can sometimes move past the edge. We'll fix that one day. This overlay is an app that we made on stream. In Godot, so any bugs are my fault primarily. All right, so let's go back here and see how I got this wrong. I guess I'll go look in the code. So originally we were turning 5 radians per second, which is not a lot when you consider. So 5. I guess divided by 30, right? I don't have to do weird multiplication. We get this value. Okay, no, so that's the exact same. That is right then. But why is it so crazy? Why is it so crazy? So we were turning this many radians per second. That becomes this many radians per frame. Well, the math is looking right, at least to me. I would love if you guys had any insights or thoughts about where I might be getting the math wrong. But in the debugger, the math looks right. We are rotating that many radians per frame. It seems like a lot, honestly, but it's converted correctly as far as I can tell. Maybe let's look at how we're using it. So turn speed. So we're taking y, which here would be a number from 0 to 1. In our case 1, multiplying it by 5, because that's how many radians per second, and then multiplying by delta, which is what's converting it into the per second part. Interesting. Let's So I made this one correction. I made this little change to the code up here, up somewhere. Where was it? It's gone. I've lost it. Wait, and why is movement vector still a vector 2? Okay, I just don't want to see that. I don't want to see any vector 2s. They're gonna freak me out. Because those are floating point vectors, and we just fixed point vectors. But somewhere here, I made that change where I said we weren't going to rotate if the vector y was 0. Vector is an SG, vector 2. Okay, let's just, I made that one tiny change. Let's try it again with that change and see if that helps us. All right. Oh, of course I still have my breakpoint. Let's remove the breakpoint. Okay, rotation is still just way too fast. Look at that. That's crazy. Okay. And we are moving like really oddly. We're moving sort of forward, sort of. Okay, let's forget about rotation for the moment. Something weird is going on there. It's not coming to me. Nobody in chat has given me any magical insights. So let's move on from rotation and try and figure out why we are not moving in the direction that we're supposed to, and instead just always move forward and backward. So that was some code we looked at a moment ago. Which I'm now failing to find. Okay. The movement vector, somewhere we were... Okay, so this code is never reached. This code here is never reached. Let's just get rid of all of that so it won't throw me off. This is the one that happens. So then we end up down here where we make a new vector where we're pointing in the direction of x, which doesn't make any sense because movement vector x could be 0, right? Couldn't it? Wait, calculate movement vector. Okay, I think I made a mistake when converting this code. Let's go look at the original version of this code. Although it looks exactly the same. How does that make any sense? I guess because we might not be moving forward? Okay, so we're not... Okay. Let's put a breakpoint here, step through this, and hopefully it makes sense. Ooh, this is wrong. Rotate rotation? That is totally wrong. Okay, fixed rotation. I might just search through this file for the word rotation and just make sure that everywhere I see rotation is not addressing the tank, and if so, is addressing it. Here we go. Yeah, so we don't want to save the position and the rotation. We want to save the fixed position and fixed rotation. This code here is run by our rollback and prediction netcode every time it's saving the state of our object. And then here we have where every time it's restoring the state of our object during a rollback. We need to make sure that both of those are based not around the floating point positions and rotations, but the fixed point ones. The pivot, we don't care about that. Okay, interpolate state. This is actually fine to be the interpolation. It's okay for that to not be with our fixed point values. In fact, it might need to be. It might need to be only the visual values. So if you guys remember from like a bajillion streams ago, we set up interpolation to run between the frames that we have from the network. So we're only getting 30 frames per second from the network, but we're displaying the game at 60 frames a second, so we need to interpolate at least one in-between frame, or if your computer's running like crazy fast, maybe interpolate more frames, so that we are sending less data over the network, but still have everything look, 60 frames a second. So here, I think it's okay. I think that's fine. Send remote update. I don't think this code is being used in the rollback and prediction. No, I don't think this is used either. That's from the old netcode. Okay. All right, a little bit of cleanup. Let's give it a shot now. Oh, I'm feeling good about this one, guys. Cross your fingers. Oh, I'm even in the right spot! And I'm at a breakpoint. Okay, let's continue. Let me back in there, guys. Oh, here we go. Get index position. Oh, okay. So it can I'm saying it's fine if it interpolates. But it's not fine if it doesn't have any data. All right. So for the time being, even though in the end we want the game to use interpolation, we are just going to not. We're just going to not interpolate. Let's comment that out. We will interpolate later, so the tank will now move like way jaggier than expected, but that's fine. Oh no, we're back up here again. Ah! Whoa. Oh my god, this is impossible. But I am driving in the direction that I'm pointing. The problem is, I appear to be rotating. Is it just that I'm rotating really fast, or is it that I'm actually rotating in the wrong direction? Wow. You just like, the tank just like flips around. I can't seem to get myself pointed to the right. Okay, I'm to the right down. Right up. Okay. Oh, geez. Okay, so we're closer. The tank is moving, but like all of the values just feel wrong. It's like rotation is just way too fast. And I don't know why we are suddenly sort of like hopping to 0. Oh, I guess I do know why. Our start positions are floating point positions, and so I guess somewhere we're going to have to convert those to fixed point positions. Lots to do. Lots to do. All right. How are we doing on time, guys? An hour in and we have a thing moving. I guess that's that's better than some streams. Last stream I felt like went really well. I mean, we didn't get done as much as I had hoped, but like, I don't know. We sat down, we had some problems, we solved them, we ended victoriously. Let's see if we can do something similar this week. So something is just wrong in the rotation calculation. I'm just gonna like lower the turn speed and either stick with a lower turn speed so that we can actually do some things, so we can move on to some other stuff, or perhaps that will like clue me into what is really going wrong here. So I don't know, what's a good sounding value? A degree per frame of turn might be okay. It's like a half a second you would turn 15 degrees. That sounds sort of reasonable. Let me get back to this radians to degrees thing, and actually we need to flip this. I want to turn from degrees to radians. Oh, come on, Google. Degrees to radians. For some reason, the drop-down boxes weren't working. Okay, so 1 degree, 2 radians. So we will convert this. 174,533. We're going to convert that into our fixed point by multiplying by 65,536. And that gets us a much more reasonable, at least to me, eyeballing it, number of 1,143, which I guess we'll round up to 44. 1,144. What? I just completely overwrote the wrong thing. 1,144. Okay. Now let's run it and see what happens. Whoa, that still feels fast. Definitely easier to work with, though. Woo! And the movement speed seems fast, too. What are we doing wrong here? Our physics process is being called 30 times a second. I don't know. I don't know. This will come to me later in the week, and I'll post on Discord like, oh my god, guys, I was such an idiot. Okay, these collisions are still working because they're using the built-in physics engine. They're not using ours. What if I just divide the speed by half? Even though the speed calculation seems like it should be correct, it like is just way too fast. Let's divide this by 2. 8, 7, 3, 7, 2, 6 divided by 2. Not in the reverse Polish calculator anymore. I'm in a normal calculator. 2, 4, 3, 6, 8, 6, 3. All right, I would like to get something colliding. You know, this is a physics engine. It's not just about going forward and passing through trees. It's about colliding with things. So I want to get those trees. I want to have us colliding with those trees, which is going to be a little bit problematic, the fact that we start off the screen. Although, we won't make the sandbags collide. We'll leave the sandbags non-colliding for the moment. And this still just turns way too fast. What the heck is going on? Yeesh. Okay, let's make this even smaller. Let's divide this in half. That'd be, what, 552 or something? You can tell how great I am at math in my head. I'm terrible at math in my head. Divided by 2, 572. 72. Let's give this a shot. Just see if the feel is good, and then we're going to jump right into trying to make the trees collide. Ooh, that is so much easier to drive. Wow. Okay. Saw something in chat. Aknakos, hey, did you know you can do all these maths in Godot too? Type the equation and select right-click, and there will be an option. I think that's how. I did not know that. I knew that you could do them in the inspector. That you could like type, fixed position. I could do 65, 36 times 10 or something, and then it would like, convert that. I did not know that you could do it in the code editor. Let's try that. Let's try that together and see how it works. Okay, so right here what I was trying to do was 1,144 divided by 2. And so you said select it and like right click. Evaluate selection. Oh! Wow! This is one of the great things about streaming. This is fabulous, being able to learn these like little tips that I would never, like, I don't read these right-click menus. In fact, I try to click as little as possible. So the Control-Shift-E would be the thing, right? So select this, Control-Shift-E. Ah, that's beautiful. Beautiful. Thank you, Aknakos. That is awesome. The Clean says that's a game changer. Yeah, for sure. That's awesome. Wow. Especially for this project where I can't have the engine calculate things at runtime because if it's using floating point math to do the calculation at runtime, it's going to screw everything up. And I need to put all these literal values in here to ensure determinism. So cool. That is great. That is awesome. All right, so we are driving. We are turning. It is not correct, but it is working. So let's go and make these trees collide. When trees collide. Ooh, this is going to cause problems in that the tree positions are all saved on a different property. They're saved on the position property. And we need to have them instead use the fixed position. That is going to be very interesting. we might, in the end, need to make a script to like read the TSCN files and do this conversion for us, which isn't the worst thing in the world. The TSCN files are very readable. I've written little scripts to read and write them in the past. Never in a terribly reusable way, which is unfortunate. Like someone should make like a Python library, someone maybe already has, that can like parse and write those TSCN files so that like every time someone has to make a little utility that does it, they could just use that library. So we might end up doing that on stream. How much time do we have? I don't know. Well, I do know, but if we have 40 minutes, I don't know if that's enough time to actually accomplish something like that. Okay, so let's start by just modifying the tree object, or tree scene, I guess I should say. Here's tree big, and it is a static body to D. We need to convert that to, oh, and let me, okay, no, from before the masks converted. So, okay, the masks should convert. I'll do change type to an SG static body to D. So that is now our static body object. And let's write down the rectangle sizes, because that we will definitely need to convert. So that is 57, 55. And we are going to, oh, I didn't need to write them down. I could have left that node there, actually, because I don't need to convert it. I can just make a new one. So we'll go SG collision shape 2D. Make our SG rectangle shape, and it is by default 10. We'll change it to be 57. Oops, I meant for that to be a time symbol. 57 and 55. All right, so there I did some math in the inspector, and then I need to just delete this collision shape 2D. And that tree should be converted. The problem is, anywhere that tree is used, let's go to our maps, which are under mods. Because this game has modding built in, I've made exactly 0 docs on how to use it. For folks who've been watching the stream for a long time, we did build a bunch of the modding functionality on stream. So that's the battlefield TSCN. The trees are still where they're supposed to be. Okay, tree big, and it's our thing. Ooh, cool. Okay, so the way we set up the nodes to sync between their fixed position and their visual position, their floating point position, is we set it up so that at runtime, you only ever sync in one direction. You only ever sync from the fixed position to the visual position, and from the fixed rotation to the visual rotation. But in the editor, it syncs both ways, because a lot of the editor tools work with the floating point position. So I think opening it in the editor and resaving it might convert all of the numbers for us, which would be so sweet. I have saved it. I didn't make any changes though, and Godot is weird about that. If you don't make any changes, sometimes it just like doesn't actually save. So I'm going to rotate this tree by 1 degree, and then I'm going to rotate it back, and then I'm going to save. All right, and then let's take a look at the TSCN file and just see, did it convert all of the tree positions? So mods, core, maps. Because yeah, everything in the game, all of the content is mods, including the core content. It's just in a mod called core. So it's battlefield. Oops, the capital B TSCN one. So that's the tile map. Fixed position. Look at that. Tree big number 14 has a fixed point position. That is beautiful. We did not do that on purpose, and it just worked out in our favor. How often is that we have a thing that automatically works out in our favor instead of goes crazy? All right, so let's try this. Let's rerun the game, and go to practice mode, and we crashed. We crashed because the script for the tree is using the wrong class name. So SG static body 2D, that doesn't matter. If I look at the rest of the code here, I think it's all fine. It's just some visual stuff. being able to switch the tree from a green tree to a brown tree. So we shouldn't get any more surprises from that. Let's run it again. Go to practice mode. We're driving. And we rode right through the tree! Okay. Of course. We did not collide with the tree on the first try. So we'll look at the usual suspects. We will eventually probably get down to the debugger in the engine in the C++ side. But let me take a look at our test scene, because we had this physics 2 test scene that we have been using while building our custom network deterministic physics engine. And I just want to, it has the collisions working great, and I want to look at the script for this scene and see if there's anything important that we are missing. So let's look at the script here. That is not the right script. Is it? Oh, it is the right script. Okay, I just didn't recognize it. Move and slide, and we're doing this sync to physics engine. The thing is, we shouldn't need to do that for move and slide, because move and slide will sync to the physics engine. It just should always sync to the physics engine. And yeah, this code kind of reflects that. So when we are moving, we just do move and slide when x does not equal nothing. And when we are not moving, we sync to the physics engine, I guess just cause. We really only need to do that like the first time, I think. We probably could even, let's try removing this. Yeah, we totally don't need that. Okay, so because we are calling rotate and slide and move and slide, we shouldn't ever have to call sync to the physics engine. And in here, we are never calling sync to physics engine on that static body that we're colliding with. Let's double check our collision masks. So the tank exists on layer 2, which is players, and it collides with layer 1, which is environment, and layer 2, which is other players. And if we go check out our tree, it is on layer 1, which is environment, and it collides with players and bullets. So that all should be fine. I wonder if there's something special because it's like from a scene, you know? Like in our test scene, this position is from the current scene, isn't from, like it's not like a scene loaded within a scene, like we would be in an actual level. I wonder if it's like syncing with the physics engine at this load time with the position 0, and then like, I don't know, that's just guessing. I'm just randomly guessing at this point. I think we might have to use the debugger, the C++ debugger. See what's going on. I mean, we could try just adding some code here to say on ready, on the ready method, just sync to the physics engine in the tree, just as a thing to try. See, Ricardo said something. I'll take a look right after I try and probably fail at this attempt. Yeah. Can you add the tree to the physics test level? Ooh, good idea, Ricardo. Yes, that would be a good way to test. Thank you. Let's add the tree. That was tree big. And let's bring it over. That tree is pretty big. And let's run this. Huh. All right, well, yeah, look at the tree should probably have like a nicer like polygonal collision shape too. But it collides. It collides fine on the test scene. So what are we doing on the test scene that we are not doing in the actual game? So we're no longer calling sync to physics engine at all in the test scene. It's all rotate and slide, move and slide. If we go look at the tank itself, that is also, when I can find it, I'll just search for rotate and slide. Rotate and slide. It's also using rotate and slide, rotate and slide. Do we still have the thing turned on where it does rollbacks all the time? There was a debug thing we had when we were using when we were still developing the netcode that would make like every frame it would roll back like 5 frames and then roll forward just to test the rollback. Where do we turn that on? It's been so long. Because that could be screwing things up because we are actually moving the position of the tank during the rollbacks without syncing, and actually every time we do that, we should sync to the physics engine. So our netcode like add-on, our netcode like library, where did we put that? That was under, I guess, add-ons, because we're eventually going to put it in the Godot asset store, so other folks can implement rollback and prediction networking. I guess that's sync manager, and one of its member variables controls that debug mode. And I have been trying to get away from editing this file to editing these elsewhere. Debug, skip nth, debug, message bytes. I would have named it debug, I think, right? Let's look for rollback ticks, because I know that we set it in the code. We set the rollback ticks. Rollback debug ticks. Thank you for using a inconsistent naming convention, past David. Really messing up future David here. Okay, so rollback debug ticks. This is set to 0 here. And network sync, rollback, debug. Okay, it's not turning it on either. We just stopped using that at some point? Okay. I do feel like now that we've realized it, we should put the sync to physics engine in the place that it should need to be for rollbacks to work, which I guess is load state. So here we would load the fixed position, fixed rotation from a saved state, and then we would do sync to physics engine. But that still doesn't help us with, or it shouldn't help us. I'd be really surprised if this magically made it work. With what's going wrong with our collision here. Nope. Okay. Are we getting to the debugger? Are we getting to the debugger? Any other clever ideas? Not yet. Not yet. But I believe in you guys. In your ability to give me clever ideas that I wouldn't have thought of myself. Okay, so let's close the editor because we need to launch the game directly from VS Code in order to debug the game. Otherwise, we would just be debugging the editor, which of course sometimes we do need to do because our physics engine includes some editor plugins. But we are worried about runtime right now, so let me change my launch.json for VS Code. Have it launch the game, not this. That would just launch our test scene. We want it to launch the plain old game. So we'll have a new little line we can comment on and off here. And let's start with no breakpoints at first. I will get the tank in position. And then set some breakpoints, hit forward, and see what happens. Compiling And launching. All right, practice mode. Let's drive our tank over here. It is right. Let me get in a position where I know I'm like right before hitting the tree. And this corner kind of worries me because I don't know exactly where the corner is. Okay, this looks like if I pressed forward, I would totally be inside of that tree. So, where do we want to brake? Where in our physics engine? I think the first thing I want to know about is what is the position of the tank? Which I guess I would get from the move and slide. Jeez, I'm so sorry for yawning, guys. I did not get a lot of sleep like this whole entire week. Let me get to, that would be, I guess, our SG kinematic body 2D, where we're going to do our move and slide. And I just kind of, the first thing I want to see is, ooh, what we broke there. Why are we moving sliding without pressing anything? That just seems inadvisable. Because we don't have the editor open anymore, I'm just going to go in Vim and change this code. Make this full screen so everybody can see. Okay, so we are not going to move and slide unless there is some velocity, so or some movement. Say if movement vector x does not equal 0. All right. Hey, Christopher Sunbaum, boom. I'm sorry if I'm mispronouncing your last name, which I'm sure I am. Welcome to the stream. All right, so let's actually, we'll kill this. We'll start it again. And I guess I will disable my breakpoint while it is starting. And try that test again. We'll roll our tank right up to the tree, enable the breakpoint, hit forward, and dig into the guts of our physics engine and see what's what. All right, so I'm driving up to this tree. Get right on the edge here. Bunch back. I don't feel like I'm necessarily going to hit the tree on just one frame of movement, but we'll find out. So I'm there. Re-enable this breakpoint. Press forward. We are now in the debugger in the C++ code of our physics engine. So first things first, I want to see what our position is. I want to make sure, because we can see our visual position, I want to make sure that our visual position and our physics position match. So how can I make that determination? So we've got our fixed node 2D that will have our fixed position. And as we drill into the memory here, piece by piece, fixed. I'm not worried about scale right now. Just give me the Y value. Where's the Y value? Here it is. Okay. Wow, these are some big numbers. Let's get a little buffer going here. I'm not going to write those down on paper because that sounds like a lot of work. So let's copy value. Oops. Let's put this into our little Vim here. That was Y, I think. That was the Y value. No, it's the X value. So X and the Y value. Oh, come on. Why didn't that go into the buffer? Okay, yeah, there it is. X and Y, they are very similar values. And let's compare that to our visual X and Y value, which we can get by really walking up the hierarchy here, the class hierarchy. Pose, this is now the floating point position. So 382.058 and 427.188. So I guess I think they're going to be correct at this point because we are updating the fixed position, which is updating the visual position, and so it'd be really weird if they weren't the same, if they weren't correct. But let's verify. We don't know until we've checked it. So 25038,566 divided by 65,536. Yep, that is correct. And so probably the y value is correct also. 1960. So that is on the node. That is not actually in the physics engine yet. So we'll keep stepping through the debugger here. We'll get into the physics engine, which this move and collide will start to get us there. So step over, step into, move and collide. Let's start stepping over. So now the first part of our kinematic motion algorithm, we need to make sure we are not currently overlapping. This should be false. So let's make sure that that's right. Cool. We are not stuck. Beautiful. So now we are going to grab the current position from the physics engine. It's going to grab this internal transform, and we're going to look at the memory for that to verify that the physics engine also thinks that we are at the position we are, which I think is this vector on the transform matrix. We just need to verify that these values are the same as what we recorded before. Yep. And this one down here. Yep. Okay, so the tank totally appears to have the correct position. I'm not going to try and verify the rotation on the transform or anything, but let's step through here. Oh, this is going to get nuts, actually, because we never implemented a broad phase. So it's going to compare the tank's position against the position of every other static body in the world. So it's going to be difficult to step through that in the debugger. Other than, I guess, just verifying that the transforms on those bodies looks vaguely correct, like they aren't all 0 or something, right? So let's keep stepping through here. We're going to see if we are colliding. So I guess I will step into, I kind of wish I knew the result of this function before I stepped into it, because I don't really care if it comes back false. Or actually, no, I do, because if it comes back false, but it shouldn't have been false, I care about that. All right, well, let's step into. This takes us into the actual physics engine. We're no longer on one of the nodes that we created to interface the physics engine with Godot. And it is going to step through a lot of bodies. So I guess I would just kind of like to verify that there's a lot of bodies there. And of course, there's a linked list. Okay, so the cached size is 21. So that sounds about right. About 21 trees on, yeah, there's a lot of stuff in here. Let me look at one of these values, see what it is. All right, so randomly I picked like looks like the third value on this linked list, which has these collision layers, which also looks right. Collision layer 1 is environment. 6, that would be bits. No, that's just single bit, right? No, that's bits 2 and that's values 2 and 4. So bits, if we start with 0, or bits 1 and 2. Bits 1 and 2 if we're starting from 0. Of course, I said this one starting from 1, so whatever. Okay, so this is this is bit 0. This is bits 1 and 2. Okay, which is right. That's correct. That's what it should be. We'll see the transform. This is the position part of the transform on this random object, which is not 0. It's not 0. So that's good. Let's look at the shapes on this object, because the shapes get their own positions and stuff. It has exactly one shape. I have to make this a little wider here. It's a rectangle, right what it should be. Check its transform. Now its transform is relative to its parent, so we would actually expect this to be 0. And it is on the X, and it is 0 on the Y. And that is what we would expect because we positioned the shape on 0, 0, didn't we? Actually, I vaguely no, on the tank, I moved it slightly to the left. On the tree, yeah, it's positioned exactly on 0, 0. So it should inherit entirely its parent position. So that seems correct. Where could this be going wrong? Let's just step through and watch how it deals with a couple of these. So we're just stepping over. We don't want to collide with ourselves. We'll test the collision layers, and it should not skip it. Sweet, it did not skip it. And then this overlapping test, let me just, I don't know, step into this one, make sure it looks right. So now it's going to loop over the shapes of both objects. Both objects should only have a single shape. So we should just move straight down to this overlaps. We'll step into this. This is where we should actually get to the sat test. Sat, I don't want you to step into that stupid inline function. Come on. Step into the interesting function. I guess we have to do another one of those. Okay, now into the sat test. Or no, not the sat test yet. Okay, first we have this sort of thing that like sends it to the right method to do the sat test. So let's step over these. We'll just do a quick sanity check on these values. Shape type, both rectangles. Yeah, it seems right. Rectangle, rectangle. And now, the sat test we've been waiting for. Here we go. And I have no idea if these should collide, because this is just the first tree in the level. And I really can't say. I cannot say why this isn't working. So this is our sat test. Everything should be fine. Our test level worked fine. Maybe we need to put rather than using that real level, let's like, I don't know, delete all the trees but one or something. Which I kind of don't want to do because I like that they all converted. So maybe let's like duplicate it, delete all the trees but one, and then we can know like for sure when we're walking through the debugger, should they collide or should they not collide. But everything up until here looks fine. Everything's looking perfect. The static bodies and the shapes associated with them seem to be set up correctly. So I guess we'll have to do what I just said. We'll have to create a better little test arena for ourselves. Let me look in chat, see if anyone's had any cool ideas. And of course, since my Chromebook went to sleep, I'm disconnected. I will refresh here. Loading. Wanna see what everyone's saying. The Clean says, I've just destroyed my 3D print, I assume printer, because it's stuck too well to the heat bed. Oh no. I really have been getting into the idea of getting a 3D printer. I don't have one. I've never had one. Because like I've been doing those electronics projects with the, my own little 6502 processor on a breadboard. Like I could make a robot or something, put it in a case. That'd be so cool. Christopher Sunbaum, what is the reason you're running your own Godot source? So we have been implementing our own custom network deterministic physics engine. And the reason is we are trying to switch the netcode of this game to rollback and prediction, which needs deterministic physics. And Godot's core physics engine is awesome, but not deterministic. So we've been trying to implement like a simple physics engine based on fixed point math. And we've been implementing it as a Godot module, which means it is compiled into Godot itself, not as a GD native plugin, which is where you'd make kind of like a DLL in Windows terms that would be loaded into Godot, which is also a possible thing to do. It's way less developer friendly. In Godot 3 and Godot 4, we're going to have GD extension, which is going to make the developer experience of creating those like loadable plugins, the DLL thing that you can load, closer to the experience of making a module. So that's what we're doing. C++, of course, being one of the officially supported languages for you to code in Godot, and we are taking advantage of it. I hope that answers your question. Let me know if you have any more questions on that line of thought. Okay, so what were we doing? We were going to go in the editor and make a better test scene for ourselves. So we want to actually launch our custom compiled Godot that we were just discussing. Debug version, come on. X11 tools 64, that's the right one. I compile Godot far too often for different reasons. I was just recompiling Godot a whole bunch yesterday and the day before because there's a WebXR bug I've been trying to get to the bottom of in the latest Godot 3.4 beta 4. Like 75% of the time, it runs unusably slow, like a frame a second. And I have to figure out what changed in beta 4 to cause that problem, since I've been testing, beta 1, 2, and 3, and they all work fine. All right. Very cool. Are you using Naaah as well? Yes, I am. So the networking in this game is WebRTC for like all of the important like gameplay messages, but Naaah is kind of like the central server that's doing user accounts and matchmaking, and a couple other just random little things. So it's like Naaah is kind of the hub, and then once you get connected into a match, all of the match data is passed over WebRTC. Networking is something I'm good at. Physics is something I'm not good at. I think we'll be able to get it done well enough that it works, that it'll be good. But guys, I'm telling you, I am dying to get back to just working on netcode rather than physics. Anyway, what were we doing? I'm way too distractible. We were making a new map. We were making a new map. We were going to take our Battlefield TSCN. We were going to duplicate it. I'm going to call it Battlefield Test 2. That sounds fine. And we're going to just like modify the Battlefield resource here. These resources is what is loaded by our modding system. We're going to modify it to point at our duplicated version rather than our original version. That will make it very easy to switch back to the real one later once we debug this problem. And we are going to just get rid of everything here. We're going to just wipe it all out. Let me make sure I don't wipe out too much. I think I can just like, yeah. I'm going to delete all objects. All 134 nodes and children. All gone. But the children. Okay, so we need a tree. Not that kind of tree. I'm in the wrong dialogue. We need... No, I keep hitting the wrong button. There we go. Tree big. We'll place our big tree over here. And let's just see if this loads. I guess I'll do it from here. I don't need to launch the debugger right away. This is a quicker button click. No, what are you doing? You're loading, and I'm stuck on something. I'm hitting something. There's something here. Or not. Well, that was weird. I got stuck for a second. So why did it load the wrong thing? Do I have, is practice mode like directly referring to that scene rather than loading it through the modding system? That's probably what's happening. Let me get up the scene that is practice mode. Oh, yeah, it is directly referring to the scene rather than using the modding system. That should probably change at some point. If we want practice mode to, I don't know, practice mode's kind of bad anyway. It could use a lot of changes. It'd be nice to have practice mode allow you to choose different maps and choose different sets of power-ups. Okay, so here we are. Oh, what? What? I'm colliding perfectly with this tree. Why can't I collide with the other trees? Oh, the plot thickens. The plot thickens. Move and slide's also working really weird. Like, why am I not sliding? Okay, I'm sliding there. I can't see the collision shape, but I feel like that should be sliding me. You know? We might need to tweak these shapes or some of our math. Because, like, look at that. I feel like that should find a face to slide me along. Like, if I were to guess at what the collision normal is here, I wish I could draw on my screen. That'd be really cool. I'd guess that the colliding face is this, would be a line here. That would be the axis, the colliding axis, and the collision normal being pointed this way, right? And I would expect him to slide to the right. That's what I would expect. But he's not. He's just sticking. So there might be a math problem, some trig issue, because we are sliding sometimes. Like there, we're sliding. But when we're hitting those corners, we're just not sliding as I would expect us to. All right. What kind of name have you picked for yourself? Screw you, Valor. I don't know. I don't know about that name. That's a weird username. But welcome to the stream. Thanks for coming. Can't you turn on Debug Collisions and see it become visible? So yeah, I can do that. Because we were running this from the editor, and because our custom physics engine was coded to recognize the visible collision shapes. There's actually some code in C++ we had to write for that to work. So it will work, at least it has in the past. So yeah, there is the collision shape. And it's of course not going to display the collision normal. And I'm going to have trouble recreating this exact situation again, aren't I? There we go. Okay, so I think the colliding axis is this axis here along this box, which would mean the collision normal is pointing this way, like you can imagine an arrow. And yeah, that should slide us, I think, downward based on this angle. It's hard to say, actually. That could go either way. But it should slide us somewhere. Why ain't it sliding us? Anyway, that is mystery number 2. That is mystery number 2. Mystery number 1 is going to be, why does this tree work and the other trees fail? Because it's the same scene. We're loading the exact same scene in here. We looked at the TSCN file, and it seemed fine. What in the heck is going on? Let's what to try next? Well, let's switch this back to the normal scene. I have the collision shapes turned on. We see the shapes there, and we see that we drive right the heck through them. Wait, okay, no, I was about to say this tank doesn't have a collision shape, but I do see it. I can barely kind of see it around the edges. Let's try like adding a new tree to the scene. I wonder if it's the conversion process that is not right here, because it was sort of surprising that it like magically converted, right? So let's maybe you could show the collision normal on screen as well as array. That would be awesome. I would that is like something I would really love, because it would make debugging some of these issues a lot easier. So like that's definitely something we could do. Oh, Valazard, thanks for coming. Wow. Sorry, I didn't know that that was your YouTube name. You know, if you chat in Discord, because I know you're a member on the Discord, and you go to the stream channel, what you say will actually appear on the overlay in like a text bubble. So you should totally chat there. Ricardo says, can you add a new tree to the original battlefield? See, you guys are way faster and way better than me. So that is a great idea. That is the same thing that I decided to do, but after you thought of it first. All right, so let's go to the original battlefield scene and let's add a new tree. All right, here's our brand spanking new tree. It's just hanging out right there. And let's try it. Come on, tree big number 21. You can do it. Ha ha ha. Okay, so something in the conversion. But this is useful though. So we will look in the TSCN for this tree and see how it differs from, say, this tree, which let's look at the names of both of those trees. So this is big tree 7, big tree 21. All right. Let's get to the right place here. Maps, battlefield. Here, I'll make this big. We'll look at it in Vim. And let's say tree big 21. Tree big 21 has a position, it has a fixed position, and it has a fixed scale. If I look at tree big 7, it has a position, it has a rotation. Oh yeah, because it is rotated. It has a fixed position, a fixed scale, and a fixed rotation, which seems fine. So the scale is, 65,536 for both of them. That's 1. So that's a good scale. These position and fixed position numbers seem fine. I wonder if the rotation is somehow breaking collision. Like if it didn't have rotation, it would somehow be fine. Let me just take another quick gander at tree big 21. Certainly let me know, guys, if you noticed anything else that I am not noticing. Let's try wiping out the rotation on this tree, on big tree 7. Although, like, I've tested rotation plenty, like in the test scene, so I don't know what could be going on here. So we have unrotated that tree. I guess I'm gonna have to remember to Control Z that later, because I do kind of want to not change the scene when we come out with the new version. Let's try that. So now our normal one that was working before, and this one's still not working. It's just still not working. Saw something in chat. By the way, does your physics system have the ability to be added as a checksum? I'm not entirely sure I understand what you mean by added as a checksum. And also, how do you move the shapes? Do you invert an input float to convert input float to a fixed point? Nope. Everything is in fixed point. So even the trigonometry for calculating the rotations is in fixed point. So if you have a node that's one of the fixed node 2Ds that comes from our physics engine, it will store its position in a fixed point transform matrix. I guess it stores its position, rotation, and scale in a fixed point transform matrix. And every time that changes, it will update the floating point one, which only controls the visuals. So assuming you're doing everything right, it should be fixed point all the way through the whole tree. Your game code will be doing fixed point math that will be setting the fixed point transform matrix on the object. So there should be no conversion from float to fixed, only from fixed to float. And yeah, let me know what you were thinking with the checksum thing. But yeah, what is going on here, guys? We can add a new tree, and it works fine. We convert one. I just do not see X resource 8. Or is it still using the same resource between the two? Tree big 7. Also X resource 8, and I'm assuming X resource 8 is just the scene that we're instancing. What on earth is going on? So tree big 7 versus, I'm gonna like open these in a buffer together so I can just see them next to each other. What? Okay, for some reason the clipboard did not pick that up. Let's try again. Probably nervous Vim typing while on stream. Tree big 21. And this is probably actually behind my face, so I'll move that up here. What could it be? Parent objects instance. Parent objects instance. Vector. Rotation. Fixed position. Fixed scale. That one has a fixed rotation, but I just removed it. So like if I were to reload this file, let's just do :E here and go back to tree big 7. Yeah, so now it doesn't even have the extra rotations on there. Let's remove the rotation. I guess it's possible that the numbers are wrong. We could calculate those by hand real quick. Check some, like turn your entire physics engine state into a series of numbers and letters. Oh, you mean serialize? To like serialize the physics state? Would be useful for debugging stuff later. What happens if you move the tree a little bit in the editor so fixed position is recalculated? That is also an interesting thing to try. Valorizard says, also does Area 2 work fixed as well? Yep, we have our own version of Area 2D that also does everything in fixed point. So I think first I'm going to try like manually calculating these numbers to see if they look right. And then I'm going to try Ricardo's idea of moving it slightly in the editor. But like, if the numbers are right, I can't see how that would help. But, you know, computers. Okay, so I'm going to do it in Python. Python has slightly better math abilities. So let's start with the 474 times 65536. That is 310,640,640,640,64. That looks right. Let's do the y value. 357 times 23396 352. And of course I was typing it in reverse Polish. Let's just do it normal math. I think it's called infix. Ooh, that seems wrong. Whoa, what did I type there? Ah, that was just my brain typing random numbers. Where the heck did I just get that number from? Times 65,536. Okay, now we get 233,963,52. Okay, so the numbers look right. The numbers look right. Well, we'll try Ricardo's idea here. We'll just move it just a teensy bit. We'll move big tree 7 just a tiny bit over. And also it's colliding with these other objects. I'm just gonna move this like completely outside of those objects. Let's save it. Let's try that. All right. No, it just drives right through. What in the heck? It's the same scene. It's being instanced in the same way. Wait, I was very briefly like sort of stuck. I don't know what happened there. What on earth? What on earth is happening? Oh man, that's sick. Well, I don't know what you're referring to, but thank you. Also, serializing and showing it on the screen would be great for checking physics desyncs later. Yeah, so there's actually a thing completely baked into the netcode to check for desyncs. I haven't used it very much up until now because after like 20 seconds, we would be desynced slightly, right? Because of the floating point math and the non-deterministic physics. But there's a thing that's built into the netcode library, whatever, which probably Lucas ported to a C# version as well. I don't know. that will, it's a mode you can turn on where all of the different clients will send their state over. Normally they don't send state at all, they only send inputs, but they'll also send their state back to the host every frame, and the host will take that state and compare it to the state that it has in its state buffer, and if there's any discrepancies, it prints it out to the log, which can be used for trying to find those kind of problems, which we'll be using a whole bunch, I think, once we actually have this physics engine integrated and working. I am just completely befuddled here. Like, why is it not colliding with that tree? Looking at the TSCN file, there's no difference like that I can detect between the two. Tree big 7 is now moved over. It has like a little fractional value here, which I shouldn't be doing. I should be trying to keep those on whole integer values for a number of reasons. Also rendering, but what is happening? I think the collision normal being visible might help. Well, yeah, there's no normal here at all because it's not colliding. Like, the collision normal is important for figuring out the slide, how much we slide, but it's like not detecting the collision at all. Okay. New plan. Here's what we're going to do. We are going to Control Z a bunch of times to get this back to where it was before. And save it. And we are going to go back to our Battlefield Test 2. Ooh, no, we're going to remake Battlefield Test 2. Okay, that's what we're going to do. We're going to go to Battlefield Test 2. You're going to delete it. Bam. We are going to... I just had an interesting thought. Hang on. Hang on. We'll push that on the stack. And I'm going to load a new thought here. I wonder if there's something weird with, like, the loop. Hang on. Let me just chase this thought down, and then we'll get back to this new test idea I have. So it's in world. I just had this thought that, like, what if it's exiting early because it's not finding a collision? Like, is that a thing that can happen in our code? I just want to look at the code for a second. I just want to look at it. Just point my eyeballs at it. Not the editor plugins. Where the heck? Collision detector. This is what I want. I want to point my eyeballs. No, not here. No, at world. Overlaps, we're checking if we overlap, blah, blah, blah. I'm going to say get best overlapping body. If it overlaps, it returns true. If it doesn't, it loops. Where's the collection of shapes? I don't know. Okay, that's probably not a thing. It's probably not a thing. Let's pop that back off the stack. Get back to the other idea I had. Okay, so my idea is that we're gonna remake our Battlefield test scene by duplicating again, and instead of deleting everything and adding a new tree, we're gonna delete all of the other trees and leave the one broken tree there, and see if we can still recreate the problem, reproduce the problem. So let's delete everything except tree big 7. This is what game dev streaming is about. Some problem that make no sense, and a streamer embarrassing themselves in front of other people trying to solve it. That's what you're here for, right? I hope so, because that's what you're getting. Let's get back to the practice scene, and we'll do Battlefield Test 2. And how are we doing on time? Oh, we've gone overtime. I'm so sorry, guys. Ah. Okay. Let's try this out, and then I think we'll have to bring this stream to a close, unfortunately. No, I did it. And it's colliding. What the heck? What is happening? This is the Twilight Zone or something. Oh my gosh. So something about the scene is causing a problem. Okay, I can't quite give up quite yet. I can't give up quite yet. Let's Control Z some stuff here. Let's get the editor up, so I'm Control Zing the scene tree. What? What did you just... I want to Control Z what I last did here, not what I last did there. Okay. So I'm going to bring back half. I'm going to bring back half of them. And now let's try it with half the objects. Unless this is actually going to load. I don't know which one is loading. Stupid Control Z affecting more than one scene is very baffling to me. Okay, let's go to script. Just make sure that practice is still loading. Okay, and it's still loading that. Okay, cool. Let's run it. So half the objects are gone. And this tree is the only tree. Only big tree that's left. And we roll right over it. What is the thing that makes this start working? Okay, I'm going to delete, I don't know, this many. Delete. After we chase this down, guys, we'll close out the stream. I'm sorry for going over time. Sorry for you as well as my subsequent meetings for the day. Because I do think I have a meeting at 1, so I got to somehow eat lunch and get ready for it. Okay, that didn't do it. Let's delete this many things. I just had a really interesting thought. What if the shape resource is not unique? What if it's the exact same rectangle is being loaded every single time, and it has the position of the last shape or the last node to have like done something with that rectangle? That is an interesting thought. That is a very Godot-ish problem in that resources exist globally and the shapes are resources. When we get down to having exactly 2 big trees, that might tell us that that's what's going on. Okay, so still not colliding. Here's what I'm going to do. We're going to leave 2 big trees, tree number 7 and tree number 8. And I am willing to bet if my theory that I just came up with right now is correct, it means we'll be able to collide with one of those trees, but not the other, because they are sharing the exact same rectangle shape resource, and they're both trying to update it with their own position. So I don't even know where tree number 8 is. All right. We're going to drive straight through that tree. Where the heck is tree number 8? Tree number 8! Here we go. And we collide with it. Oh my god. This is totally a problem. That's the problem. Wow. And I never encountered it before because I was not instancing scenes. And the reason our new tree worked when we added it is because it was the last tree in the scene tree. Oh my gosh. Wow. That's totally what the problem is. We do not have enough time to fix it right now, I don't think. I mean, I'm just going to take just a quick peek. I'm just going to put it in front of my eyeballs and okay, so that would be in the collision shape 2D node. It contains a resource, which is, yeah, this get shape, this SG shape 2D is a resource, and it would be the exact same resource for every instance of the tree. And so when collision shape 2D comes in here and says sync to physics engine, which calls sync to physics engine on the shape resource. Oh man, what is the fix for this? We need the shape resource to actually create more than one internal shape within the physics engine. So we can no longer have this one-to-one between the shape resource and the internal shape in the physics engine. We need to have, and the only way that we know it's being used multiple times is from the perspective of the SG collision shape 2D node. So it has to be something here. This collision shape 2D node is going to need to store the internal version of the shape, and it's going to need to ask the shape resource, like, hey, go make me one of you. Rather than right now, the shape resource just creates one instance of the internal shape. Because like, look, we have SG shape 2D internal. This is the internal physics shape. Wow. Okay. Well, I know what I'm doing next. Let's go see what's going on in chat. Could add 2 trees to the physics test scene. Yeah, so that would definitely answer if this was the thing. And you know, maybe let's do it. Let's just do it right now. That'll be our last thing. We'll do Ricardo's last suggestion, and then we're gonna bail. And thanks again, everyone, for coming. We're going to just duplicate this tree. We now have 2 trees, and the upper one is the second one in the scene, and I bet that one is going to collide, and the other one is not. So here's the first tree, no collision, and here's the second tree. Yeah, so we know what the problem is. Wow. Well, we found a fundamental architectural design flaw. I guess not fundamental. This is sort of a fringe part of the physics engine, but it is a flaw in the architecture of our physics engine. Nothing deep like in the math, just in like how we're allocating these internal shapes. And I'll fix it. I'll fix it over this next week and advance things a little bit before the next stream, and we'll get to our next crazy, difficult to debug problem next time. So thanks everyone for coming to the stream. Hope to see you next time. Have a great weekend if you're in the United States. It is Labor Day on Monday. I'm traveling to go stay by my pa over the weekend with my daughters. It's going to be a good time. Hope you guys have a good weekend as well. Take care. Bye-bye.